Hello guys, welcome back to Horror Labs YouTube channel. Now, in today's episode, we're going to be looking at the chapter two of like the Cairo book, which basically looks at common programming concepts in Cairo. Now, as an existing developer, you've probably noticed that a lot of programming languages share the same fundamentals, right? They are like literally the same concepts or concepts that repeat across like the different programming languages you've tried out. Now, Cairo is not so different. There are like some strong concepts or fundamentals you've probably been exposed to while learning previous programming languages that exist also even within like Cairo, and we're going to be looking at those today. Now, if you're just joining us for the very first time, I would advise you check out the previous episode where we looked at writing your first line of Cairo code, that's printing hello world to like the terminal, because there we also got to set up our development environment, that is cab, which is very important to like being able to like follow up on this particular episode. And also don't forget to like, subscribe and hit the notification bell. And without further ado, let's get started. So the very first subchapter we're going to be looking at is variables and mutability. And under this subchapter, we're going to be covering stuff like the mutable memory of Cairo. We're going to be looking at how you can make your variables mutable, basically how you can create mutable variables. We're going to be looking at other concepts such as variable overshadowing, constant, and so many more. All right. So probably you've heard that Cairo has or uses like an immutable memory model, and it sounds confusing, right? Because coming from probably different other programming languages, JavaScript, and so on and so forth, right? You've probably been able to easily mute it a variable you probably created. So let's say you previously created a variable, say x is equals to 3, right? You can easily just change the value of that variable at another point, right? From x equals to 5 to x is equal to 6. Now, while of course Cairo having an immutable memory model helps prevent like a lot of unnecessary errors that developers would probably run into or could probably cause accidentally, right? It also has its downsides, because I mean, not being able to create mutable memories can sometimes be very annoying, right? But thanks to Cairo 1.0, which comes with it means for you to create mutable variables, a process handled by the compiler. It's possible right now, like I said, to create mutable variables. But of course, it doesn't mean that okay, the Cairo should I say the Cairo memory model became mutable, right? But it's just a little workaround which is done at the compiler level, which of course we're going to be looking at. Now, what do we exactly mean when we say the Cairo memory model is immutable? Let's switch to our VS Code, right? Our code editor. Now, say we create the main function. Like I said, the main function is the most important function within your Cairo program. It's like the entry point into your Cairo program, right? So we're going to create the main function, and we're going to create a variable. So let's say this variable is x, which is equal to 5, right? Now let's try to see if we can overwrite that variable, right? Overwrite it at put another value in its place. So as you can see, we're getting an error. It says cannot assign to an immutable variable. Now if you try compiling this, now let's run scarp build to compile. If you are not very familiar with these commands, then it means you probably skipped the previous video. I would advise you to go check it out before coming to join us on this particular episode, right? So you can see the compiler throws an error. It says cannot assign to an immutable variable, right? So that is because you can't change the value of an existing, you can't exactly easily mutate the value of an existing variable, right? But like I said, thanks to Cairo 1.0, right, there's now a high level syntactic sugar called mute you can actually use to do this. So for example, I could do something like say let's mute x is equal to 5, right? And with that I should be able to like add another value in this place. So as you can see, the error just disappeared. And if we try to compile that particular contract again, you would see that it compiles. So as you can see, it compiles. Now the question is, how exactly does this work? Like, how exactly does this work? So just like I mentioned earlier, let's go back to our browser. So like I mentioned earlier, right, the whole immutable memory of Cairo didn't really exactly change, right? But the process of the way Cairo achieves mutability, right, is whilst like the, what's it called, the value written to that particular memory cell cannot be overwritten or changed, right? It's possible to, how will I put it, right, to redirect that that variable, right, the initial variable that was declared, to point to another value in the memory cell. I think it would be easier to explain this with like a diagram. So let's just come into this and let's create, let's use a simple rectangle, right? So let's assume this is a variable. I'll call this variable 1, right? And variable 1 probably points to this circle, which is like you point in Cairo's memory. So to variable 1 we wrote the value of 5. So I'm going to use an arrow. Sorry, my diagram sucks, just not very good at distance. All right, so I'm going to, sorry, okay, yep, so I'm going to use this to point to this. Now as you can see, let me zoom this in a bit. All right, so I think this will be very much visible. So as you can see, right, we have variable 1 which points to like 5 in the Cairo memory, right? Now this is like a memory cell and this is not mutable. So then how can we exactly change the value assigned to this variable? Now when we use the mute keyword, the compiler does something, right? So essentially we create another what's it called, another value in the memory cell. So let's say in this case we want to write to 6, right? And we just redirect it. So rather than variable 1, this variable we declared earlier pointing to 5, so essentially we take it to point to 6 instead. And that's the reason why when you declare a variable as mutable, you can basically change the value assigned to that particular variable, but you can't change the type of the variable because it's the same variable, but this time around like it's the compiler points it or forwards it to like another, basically the new variable which was assigned to it. So essentially every time you call variable 1, the compiler would return 6 instead of 5, and that's just basically how the compiler achieves the concept of mutability. So like I said, the one thing I want to point out right from the whole thing is, right, Cairo's memory still remains immutable, right, but the whole ability to create mutable variables is more or less like a high level syntactic sugar. So let's just read from the Cairo book. So it says, okay, we've gone through some of all these things. So it says, however, I might be wondering at this point what exactly happens when a variable is declared as mutable. So as I previously mentioned, the Cairo's memory is immutable. Okay, we looked at this. The answer is that the value is immutable, but the variable isn't. So like I said, the value associated to the variable can be changed, which is basically what we do every time we declare a variable as mutable. So this is the same example as what we did, right? So we declared a variable called x, which points to 5. We declared it as mutable. So you basically declare an existing variable you've created, right? You can declare a variable as mutable by adding like the mute keyword, and then we can just simply like what's it called, write another value to it. All right, so the next thing or the next concept we're going to be looking at is constants. Now, constants are very, let's say, similar to like immutable variables in the sense that you can't mutate a constant, so they are expected to like remain, as the name says, constants, right? So constants are actually very useful for when you have like certain variables that are used like in different parts of like your contract, right, or within like basically different parts of your contract. You just need to like probably declare them them in like the public scope, and you can basically use them like I said in different parts of your contract. So because of this, right, constants are expected to be set like within the global scope. So it's not really advised that you go start setting your constants, let's say within like a particular function or method. Some other things, right, need to know about constants is that you can't use the mute keyword with it, right? So when we looked at the concept of immutable variables, right, we also talked about how you can create mutable variables using the mute keyword. Now it's way different for constants. So for constants, you can't like make a constant mutable by adding the mute keyword. Now let's just dive into like our code editor. Probably would help with seeing these things happen in real time. So for example, how to declare a constant, right? First you start with like the const keyword, and I'm going to declare a simple constant named hello. The next thing you need to do is specify the data type for your constant. Now once I want to create a short string, so I'm going to use data type felt 252. Finally, you have to assign like your constant variable. So in this case, I'm just simply going to type hello. So as you can see, right, we like I said, we start with the const keyword, then we declare our constant name in all caps, which is like very important. So this is like the common standard we use in StackNet. So you need to use all caps like for your constant name. Then next up you declare like the what's it called, the data type for like that particular constant. So without this, the compiler is going to shout, so you need to like include like the data type for like the constant. And finally you can now pass in the constant you're trying to declare. Another thing you should know about constants, right, is you can only the what's it called, the right hand side of your constant, that this value here, has to equate to something that's definite or known at compile time, right? You can't use like stuff that have to be computed during runtime. For example, the value of, let's say, a function within your program or something like that, right? The compiler is going to shout. Another thing I also mentioned, right, is that you can't use the mute keyword with constant. So if you come here to say constant mute hello, this is going to shout. As you can see, the compiler says okay, unexpected token, so you can't do that with constants. Some other things you probably need to know about constants, right, is you can do a whole lot. You can like you can specify struct as constants, you can specify enums as constants, you can specify fields, different data types as constants, right? But like I said, it has to be something that whose value is like known during the compile time. So going into the Cairo book, you can see like from the examples here, the struct was declared as a constant, and then was declared as a constant, even like a fixed size array, in as much as, like I said, it's not at compile time. So you can actually declare a fixed size array as a constant. So if we go into a code editor, right, so aside this, right, we could also do something like what's it called, we can say declare a struct. Let's call the struct let's just call these numbers, and I'm just going to say I'm going to say A is going to be of the type uint64, and B is going to be of the type uint256, right? Now this is sorry, uint256. All right, so this is like a basic struct, so I can actually create a constant out of that struct. So I'll call this constant num, and it's going to basically be of type numbers, right? And it's going to be equal to, I'm going to declare the value of numbers. So I'm going to say A should be 24, and B should be, I don't know, 25. And so with that, as you can see, we just declared a struct as a constant. We can also do like for enum. So let's say I have an enum, call this my enum, right? And this enum probably has E, which is like E, let's see, A felt 252, and we have B, which is like a tuple. Let's say you're in 64 or you're in 32, just using random stuffs here. So you can actually also declare this. So let's call this mine. So I really suck at naming variables, right? So this is going to be of type my enum, and we could basically just refer to my enum, and I'm going to refer to the value, what's it called, the value E, right? And could just simply pass it hello, and yeah, now we declare like an enum as a constant. So you could do for like, you can declare like a lot of existing, like most of the existing data types in Cairo as constant, like I said, in as much as the value is known as what's it called, to compile time. So if we try to build this, let's see if we run into errors. We shouldn't, right? Because all these are like um valid constants. All right, so the next thing we're going to be looking into, right, is the concept of what's it called, the concept of shadowing. So last time we mentioned something as regards, we talked about mutability, right, and how you can basically use it to change the value assigned to a variable. But you noticed we also mentioned that you can't like change the data type associated with that variable. Now let me show you something. I don't think we got to demonstrate this earlier. So going back to my code editor, I'm just going to, okay, I'm just going to create the main function again. So within this main function, I'm going to create a simple variable or a mutable variable. X is equal to 5, right? Now, you would notice if I try to do this, if I say X should be equal to felt 252, which is basically like the data type for X. Now, recall I declared this as a mutable variable, right? Now I come here and rather than use the initial, oh, right, sorry, both of them are failed to 52s, right? So let's do something else. So I'm just going to declare this as, let's say, let me declare this as a uint32. All right, so now X here is a uint32, but X here is a failed 252. So as you can see, the value, like a compiler shouts as you see, the value does not fit within the range of the type core integer uint32, right? So with mutable variables, you have to stick to like the same data type as what you had before. So if I switch to, let's say, 6 uint32, right, the compiler does not shout everything is okay. So but the question is, how can you create variables, right, with where like in as you can also mutate like the data type. Now that's where, what's it called, that's where variable overshadowing comes in. Now with variable overshadowing, the concept is very like it's very easy. So we have, let X be equal to 5, right? Let's do the same thing in 32. Now when we try to overshadow a variable, we make use of the let keyword again, the same name, but now we can actually use, what's it called, right? So we can now use like a different what's it called, data type. Now if I try to print the value of X, right, you would actually see that we, what's it called, we get so if I try to print the value of X, sorry, right, you see that we get this what's it called, this second value here, which is like the felt 252. So I'm just going to run scarp Cairo run. All right, so you can see here it prints like the felt 252 value of what we typed in here, right? So that's basically like the difference between what's it called, variable shadowing and mutability. So with mutability, you get to like replace the value assigned to that particular variable, but you can't override the data type, because essentially we are not creating a new variable. We're just like creating like a new value and pointing that variable to that new value. But with variable overshadowing, right, with shadowing basically, we're creating a new variable. So we have let X is equals to 5 uint32. Then we come here and we use the let keyword again. So essentially we're creating a new variable with the same name. Now what happens anytime we try to call the value of X in the scope of this main function, right? The compiler looks like for the most latest version of the value X, which in this case is this, right, which was where we wrote it to like the felt 252 value. So that's just the simple difference between what's it called, variable shadowing and variable mutability. It's important to note this so you can understand how to use them. Now going back into the Cairo book, right, so I think we've looked into most of this. Yep. Okay, yeah, I think that's as much as we need to cover for like this particular subchapter. And the next subchapter, we're going to be looking into the different data types that exist in Cairo. But before we move there, so let's just take the little quiz here to see if we got like a very good understanding of this particular subchapter. All right, so the first question says, which syntax creates a variable that can be reassigned? All right, so in other words, which syntax can you use to create immutable variable? In that case, it's this, right, where we add the mute keyword. Now submit that. Next question says, what will be the output of the following program? Now let's look into this. So it says, initial balance was set to 9. The next initial balance was set to 9 minus 3. So in this case, you can see like the variable initial balance was shadowed here. So we have like it's set to this new value 9 minus 3, right, which is 6. Now, if you notice, we have like this curly bracelet, which means like another existing scope. So in this new curly bracelet, right, we have let initial balance be equal to initial balance times 2. Now, in within the scope, right, the value of initial balance has been shadowed again, and it's probably going to give us like what we had here, which was 6 times 2, 12, right? But now we come out of the scope to print like the final balance. Now, think about it, pause the video and think about it. What should our initial balance value be? All right, so we set it to 9, we come here, we set it to 9 minus 3, we shadowed it here, it becomes 6, right? So this is another scope entirely. So within this particular scope, the value of initial balance is meant to be 12, but we print out of like this scope right here, right? So this print statement is just a continuation of this previous scope. So it means that our initial balance value is going to be 6. Now let's check if that's correct. So our final balance is 6. Now let's submit that. All right, so we got both of them correct. All right, so that means we had a good understanding of variables and mutability. Now we are going to be moving on to the next chapter where we get to look at data types. Okay, so in this next subchapter, we're going to be looking at the different data types that exist in Cairo. Now, Cairo in particular is like a statically typed language. This basically means that every variable's data type rights must be known at compile time, and there are like a lot of data types like within Cairo, and we're going to be classifying data types rights within Cairo into two. So we're going to be looking at the scalar data types, and we're going to be looking at the compound data types. The first scalar data type we're going to be looking at is the felt 252, which is like the probably like the most popular like data type in Cairo. So before the introduction of unsigned integers, assigned integers, and so on, with like it was it called the Cairo 1.0, right? Cairo 0 had like just felt 252s. They are essentially like what makes up like the very base of Cairo, right? So in essence, every variable that is not specified or given like a particular data type always defaults to like the felt 252 data type. So felt 252 stands for field elements, right? And it's basically an integer within the range of 0 to x to like a very large prime number called b. So you can see that in here like the value of b here, right, which is 2 raised to power 251 plus 17 times 2 raised to power 92 plus 1. Well, basically what we're interested in currently. Now the problem or the challenge like you basically have with like field 252, right, is well it's very much subjective to like a lot of underflow and overflow issues. So you can basically carry out like different operations, addition, subtracting, and multiplying, right? But when it comes to division, filters are created in such a way that they must satisfy a particular equation. So you can see this equation here which says x over y times y is equals to x. So in essence, what it's basically saying, right, is like the variable dividing the other variable, right, must basically divide without like having a remainder. So it's more or less like when you try to divide, let's say 4 by 2, right, you get 2. So you have 4, which is x, and you have let's say x is equals to 4, right, and you have y is equal to 2. So this basically states that 4x over y, which is in this case 4 over 2, right, multiplied by 2 should always give you x. So in this case, if you divide 4 by 2, right, you get 2. If you multiply it by the what's it called, division, so in this case 2, right, you would get back the initial value of x, which is 4. So every result of division in Cairo, right, must satisfy this equation, and every single time it doesn't, right, like Cairo makes it that it must satisfy it. So in a case where you're trying to like divide two numbers that results in a remainder, rather than having like with most programming languages, right, probably have like let's say you're trying to divide 7 by 3 and you're going to probably have 2 point something, right? But with Cairo, you're going to have like a very strange long number that you really do not understand, and which can like cause a lot of problems with like your program. And that's the reason why the integer data type was introduced. So the integer data type, right, is basically uses felt 252 under the hood, right? So but basically it gives you the possibilities to create both unsigned and what's it called, signed integer data type. So we have like I think there should be about the 6 or 7, 1, 2, 3, 4, 5, 6, 7, right? So we have the 8 bits, which is basically the UINT 8. We have the UINT 16, the UINT 32, the UINT 64, the UINT 128, the UINT 256, and the UINT size. So this UINT size is basically like same as a UINT 32, right? Probably no much difference, but will probably be useful with the introduction of MLIR. So it's basically how the, should I say, the most recommended like data types to use, right? So okay, let's just move into, I think we've been doing a lot of theoretical work. So moving into our code editor, right? So I already created this file called datatype.cairo, and we talked about the failed data type, which is very simple to create. So we can do this using like let's say specifying data type, which in this case is failed 252. So let's say this is equal to 12, right? So sorry, let me create the function first, forgot to do that. Alright, so let x failed 252, and we say this is equal to 23, right? So this is valid, and in a case where you do not even specify any data type, right, this would always default to like a failed 252. But like I said, you do not want to use this within like your program or your smart contract. You need to reduce like the number of times you use failed to as minimal as possible, right? So it's rather advised to use either use integers, right, either unsigned integers or like signed integers. Now to create, let's say I want to create an unsigned integer like a uint 8, right? So I could do something like let x be equal to uint 8, and I could also say 23, right? But in this case 23 is going to basically be a uint 8 instead, right? Because we specifically specified that we want this to be a uint 8. Another way you can also do this, right, is using what we call numeric literals. So we could do something like I want this to be 23 units, and this also defaults to like what's it called, an integer. So you can see here that the type is the core integer uint 8, right? So there's also like you can do for the uint 16, which is just overshadow. So you can do for the uint 16, the uint 32, the uint 64, uint 128. Yeah, so back in the Cairo book, so you can see we use basically struct with two fields, right? The low value, basically 2 uint 128 values, right? Yeah, and Cairo also has support for like what's it called, signed integers, because on signed integers you can basically use like signed values, for example values in the negative, and for those kind of values you want to use stuff like basically signed integers. So you have values with size ranging from I8 to I128, where each sign variant can store from minus 2 n minus 2 raised by n minus 1 to like 2 raised by n minus 1 minus 1, right? So for example, for an I8 value, you can basically store values from minus 128 to like 127. Yeah, so the next thing we're going to look at basically is the different types of numeric operations that you can carry out on integers. So like every other programming language, Cairo like supports the ability to carry out numerical operations on like existing integers. So for example, you can carry out summation, you can carry out subtraction, products, quotient, remainders. So back into our VS Code, right, we can do stuff like, okay, we can see x is going to be the value of, let's say, 1 unit, let's use un 16, right, plus 2 un 16. So you can basically do something like this with subtract, addition. You can also go subtract, right? So want to say let x be equal to want to say maybe 5 un 64 plus 10 un 64. So you can also do the same for what's it called, for product. We can say 10 un 128 times 5 for u into 128. And you can do for, or what's it called, you can do for division. To do for division, simply just replace with divisor. You can also do for like modulus and so many other. Right, so Cairo supports like what's it called, all this. We have next the next data type we're probably going to be looking at, right, is like the Boolean data type. So we are all familiar with like what the Boolean value is, right? And in Cairo they are basically represented with like 1 felt to 52 in size. So you have like the true value, you have the false value, so you can basically create Boolean values. So we want to say we can say let t, which is basically a Boolean value, be equal to true. We can also say let it be equals to false, right? So we can also, I wasn't really share my screen, right? So you can specify your Boolean value. This can be false, it can be true, whatever, right? So Cairo has support for Boolean values. Cairo also has support for string types. So we've looked at strings, right, a little bit in like most of our things we've done, right? So we talked about how strings are not supported natively, but you can basically use felt 250 if you have 250 representation for short strings. So you can do stuff like what's it called, like as we've always done, right? We could simply just create, let's say let y be equal to hello. So this is like a short, what we call a short string in Cairo, and it's basically represented using a felt 252 value. But the what's it called, the limitation with this, right, is you can represent just I think about 31 characters. Above it the compiler begins to like shout at you, since like it's basically exceeds, what's it called, it exceeds the value of like a felt 252, right? Because each what's it called, each of your character is represented using, I think, about 8 bits. So you multiply that by 31, you're having about 248, and that's like which basically means you can literally fit in just about 31 of that into like a felt 252, which is about 251 bits. All right, so if you want to represent, what's it called, if you want to represent something longer, then what you can probably do is using what we call a byte array. So with a byte array, I could, by the difference in byte arrays, short strings and byte arrays, right, is with the byte array you probably declare a byte array using like, what's it called, a double colon. So I could say hello world. You could basically write even longer strings. Okay, let me try to infer this. Seems like the compiler can't. All right, so this is like the byte array type, and with that you can create way longer strings, so you can write in a whole lot of things here longer than like the 31 characters limitation like of a normal short string. The next data type we're probably going to be looking at, right? I've already looked at byte array, right? It's the tuple type. So when I started earlier, I talked about how we're going to be looking into two different data types: the scalar types and the compound types. So the tuple type fall under what we call the compound type. So essentially, compound types are how, like, basically what we use for like grouping stuffs together, right? So the tuple type is one. We have the tuple type, we have the fixed array, and a whole lot of others we're going to be looking on. So let's just get started with like the tuple type. So I'm going to head into like what's it called, my VS code, and let's create our first tuple. So with tuples, right, you basically specify. So let's say I want to create a tuple of names, right? And I want this to be, what's it called? It can be, I want it to be like two felt 252s, right? And we could basically say I'm going to Darlington, and the name probably will be, all right. So this in itself is what we call a tuple. So you could create a tuple with the same data types. You can also create a tuple with different data types. So let's see, I'm going to call this let's name and age, right? So let name and age, the name is going to be presented using a field 252. The age is going to be presented using like a UNT 64. So I'm going to say Darlington, and I'm probably going to just say 21, right? So this is how you would basically create a tuple. And what you probably can use, like I said, you can use tuples to like group stuff together, probably of the same data type or like of different data types. Now to like get the value of, let's say, its name and age, right? Could basically to like get the value for tuple, we can basically destructure it in such a way that we can say, okay, we want the name and the age, and we want both of them to be equal like to the name and the age tuple, right? Once we do that, we could just simply print out the name, right? And we could print out the name. Now once you run scab Cairo run, let me just clear this terminal, it's too clunky. And when you run scab Cairo run, you get printed out the felt 252 representation of the name Darlington. You could also decide to, let's say, destructure it right from where you're declaring the tuple in such a way that we could do, okay, let's just call this x, y, and I want this to be of like a felt 252, felt 252, and this is going to be equal to two felts, let's say 2, 3, sorry, then 5, 6, yep. So we can simply just print out just let's print out x, and you should get like the value of 23, right? So I'm going to clear this once again, run scap Cairo run, and as you can see, the value 23 gets printed out. Now the next data type we're going to be looking at, right, is the unit type. So the unit type has only one value, which is like, as you can see, declared by like an empty parenthesis. So it's basically like a tuple with no elements. And the reason why it's important is because everything in Cairo is basically an expression, right? And so for things that do not return anything, for example, when we when we declare our main function, right? So as you can see, this main function does not really return anything. Under the hood, it returns the unit type, right? Because like I said, everything has to be an expression. The next data type we're going to be looking at is the fixed size array type. So the fixed size array type is another wonderful means to write, have like a collection of like different values. And of course you can't come do not confuse it with like the array t type, which is another like another method basically you get from the core library that helps you like declare dynamic arrays. So with fixed size array you have to declare the what's it called, the type, data type of the elements of like the array, right, and the number. So the all, so with the fixers array, right, all the elements has to be like of the same data type. So let's try creating our own fixed size array. So heading back into our VS Code, right, so we want to create our own fixed size array. We could simply just do array, want our array to be of a fixed size. Let's say you in 32, right, it's going to have like 5 elements, and we can just simply declare it 1 2 3 4 5 and close that. So this is basically how you declare a fixed size array. You can also declare like a fixed size array, right, without like, for example, what we did here. A good example, all right, that's what I'm looking for, right? Example. So a good example of how you probably want to use fixed size array, right, is as you can see here. Let's say you're trying to define something like the months of the year, which is of course like fixed and known at like compile time, rather than having to what's it called, use like a dynamic array like the array t type you get from like the core library, which basically ends up using unnecessary runtime memory. You can just basically like use what's it called, like a fixed size array where you declare like all the months in here. As you can see, January, February, March to December. Now this is better because this is like no, not compile time, right? So it doesn't require like any sort of runtime memory management. So it's like a very useful. Do play around with it, right? So the next thing we're going to be looking at is accessing fixed sized array elements. So yeah, so as a fixed size array is data structure which is known as compile time. It says its content is represented as a sequence of values in the program bytecode. So accessing an element of the array will simply read that value from the program bytecode efficiently. So for example, you have a fixed size array that's declared here. So you can just basically like access it this way, just similar to how you would access a tuple, right? So let's go ahead back into our VS Code. Let's say we're trying to access the elements of this particular fixed size array. We could just simply say we want x, y, z, and there's that should be 5, right? 1 2 3 4 5, sorry. So we want this, right, to be equal to array. Okay, so what we're essentially doing here is we are specifying the elements we need, which in this case is 1 2 3. So when we specify that, we're basically telling the compiler discard of this particular element. We don't really need it, but if we want to use it, then we can just assign it like its own variables. So anytime you call x is going to return 1, y is going to return 2, z is going to return 3, u is going to return 4, and v is going to return 5. So that's basically how you access what's it called, fixed size array. Now once we've got that out of the way, the last thing we're going to be looking into to call this sub chapter, to come to the end of like this sub chapter, right, is type conversion. Now we've looked into like different data types, right? Something that's probably be very important to you as a developer is being able to like convert within types, right? So let's say I have if you're 252 and I want to convert it to you into 6. How do I do that? Now, Cairo provides us with like two methods, which is basically the try into and the into methods. They are available like within the core library. You can check them out. But the basic difference between both, right, is the into is more or less like should be used where you are sure like that success is guaranteed, because otherwise it's going to panic, right? So you want to use it where like you're sure like the conversion success is guaranteed. For example, when you're trying to convert from like what's it called, a smaller data type to like a larger one, where you're sure like the smaller one is going to fit into the larger one, then you could basically use into in those cases. And the way you basically want to use it, right, is okay, let me yeah, the way you want to use something like that, right, is, for example, I have let's call this variable uh one. So sorry, I really suck at naming variables. All right, so I have one which is supposed to be like a in 64, right? I could basically convert. Let's say I have 10, which is a unit 8. I could basically 10 unit 8 dot into, right, and this would convert one this 10 units 8 into one, which is of course like of the type you in 64. So 10 becomes like you in 64 value, right? And for the trying to method, you want to use trying to where like there's maybe little chance like that the conversion might fail. For example, when you're trying to like convert from what's it called, a bigger, what's it called, a bigger value, right? You're probably trying to convert the source value is like bigger than the value you're trying to convert to. In those cases, you might want to like what's it called, use a uint trying to, right? So let's say I have let this variable calls 2, which is a uint 32, and I'm trying to convert this variable called this uint 64 variable into it, right? In those cases, I'll probably want to use like the try into method, and when you use the try into method, it returns like an option T type, so you probably want to like unwrap that to get the value. So yeah, those are like the two major type conversion mechanisms you'd probably want to like use within like your Cairo smart contractor program. Yeah, so you can also look into like other different examples on how this was used. And with that, I would say we've come to like the end of like this particular subchapter. So as always, we're going to probably try to take the quiz to see if like we got like a good grasp of most of the things specified. So yeah, so the largest number represented by the type I-128, right, should be 2 raised power 127 minus 1, so recall 2 raised power n minus 1, yeah, minus 1. So this should be 2 raised power 127 minus 1, so I'm going to pick that. So if x unit 8 is equal to 0, okay, what will happen when you try computing x minus 1? So this is an unsigned integer, and you have value 0. So if you do 0 minus 1, it returns a signed integer, which is minus 1 basically, and you can't what's it called, assign a signed integer to an unsigned integer. So this should panic, right? It would always panic. Then next question says determine whether the program will pass the compiler. If it passes, write the expected output of the program if it were executed. Okay, so we have this function, the main function. It says let x felt 32 is equal to 2, print line. So yeah, this would obviously fail for the reason we do not have like a felt 32 data type. It's rather a felt 252 and a uint 32, so this should not compile. Now let's submit. So we got this correct, we got this correct, we got this correct. So that's great. Then it means we got like a very good understanding. So in the next subchapter, we're going to be looking at functions. Yeah. So functions are very important. Of course, they are like very one of those like widely spread concepts you would find like in every programming language, and of course you would use them a lot within like your Cairo programs or your Cairo smart contract, and probably you'll need to functions, right? Everything we've been writing thus far, like functions, the main function, everything we've been writing, we're writing like a lot of functions, particularly the main function. So the convention or the standard basically we use within the Starknet ecosystem for functions is like the snake case. So you want to like specify your function as like a snake case. By snake case we mean so if we switch to our editor, all right. So I'm just going to, okay, so for example we have the main function here, right, which is like a one-worded function. So if I want to create another function, let's say, okay, for this let me just save this, right, uh take this out, sorry, that was added by the LSP, so I'm going to take that out. I'm going to create a new file. Let's just call this function functions.cairo, so it would help us categorize all this. All right, and within the lib I'm just going to, yeah, going to comment that, and I'm going to mod functions. Okay, all right, so within our functions, for example, as I was saying, right, if for the main function you it's like a one or that, so we could do something like that. But let's say we had like something like subtract number, right? You want to do that using like what's it called, a snake case. So this is what a snake case is. All right, moving on, right, it says we define a function in Cairo by entering the fn followed by a function name and a set of parentheses, something we've probably done time and time again. So the curly bracket tells the compiler when the function body begins and end. So this curly brackets is, I prefer to call them bracelets, whatever I call them, right? So this brackets here and here basically like tell the function where like the tell the compiler where the function logic begins and ends, right? So we can call any function we've defined by entering its name followed by a set of parentheses. Okay, so now that we define another function before the main function in the source code, we could have defined it after as well. So another thing that's very important, right? Cairo doesn't really care where you define your functions, only that they are defined somewhere in a scope that can be seen by the caller. So you can define your function in whatever arrangements that suits you, right? But just ensure like they are defined like in a scope that can be seen by the caller. So we have the concept of parameters, right? So parameters are basically what you supply to like a function. So some others call it like arguments. So since technically concrete values are called arguments, but in casual conversation people tend to use the word parameter and argument, of course, which is like a lot of us use it interchangeably, right? So but so parameters are basically what you pass in here, right? Then I think arguments are like what you pass in here. So 5 for example, which this is just like a parameter, then 5 in here is like an argument. So if we want to, okay, let's say for example we are creating a function called subtract number, which takes in like let's just do proper standards, taking even 16 and y is taking another UN 16, right? And so this should basically return x minus y. Okay, so the other thing we're going to be looking at, right, is the return value for functions. So when a function returns a particular value, we specify the return type using like the arrow, then the return data type. So as you can see here, the subtract number basically subtracts two UN 16 values and returns like a UN 16. So you just specify data type alone, you do not do something like z UN 16, that'll be wrong, right? Just the data type that's being returned. And of course, like I think we've mentioned this previously, right? When you do not end like an expression with like the semicolon, right, the compiler automatically returns the value of like the expression. So to use the subtract number within like our main function, we'll probably want to call it like call subtract number, and we can pass in like our two values, which is x and y. So one subtract 10 and 6. So once we do that, this is going to call the subtract number, passing in these two parameters, and basically return the value. So we can say, okay, we want to assign that to like a value z, and we can try printing out the value of z. So print out the value of z. So if we clear this and run Cairo run, so it should give us a value of 10 minus 6, which is 4. Okay, so back into the Cairo book again. The declaration of another function has one parameter named x. The type of x is specified as, okay, basically like explain the examples. Well, when defining multiple parameters, separate the parameter declarations with commas like this. So we looked at it when you're passing in like multiple parameters or multiple arguments, right? You want to separate them using like a comma. Skip all this. So the next one to look at is name parameters. So in Cairo, name parameters allow you to specify the names of arguments when you call a function. This makes the function calls more readable and self-descriptive. So this is like optional, but basically makes your your code easier to read, right? So if you want to like be more descriptive, you can basically use like stuff like name parameter. So the syntax is you want the parameter name, a colon, then the value. So it says if pass a variable that has the same name as a parameter, you can simply write this parameter name instead of parameter name variable. So let's try that out. So we move into like our VS Code, and we want to pass in this as name parameters. We could actually do stuff like this, right? So we can do this. This is going to like still return the same value. So we try to run that. You can see it also returns 4. So if we also had, let's see, we had them described previously declared, right, and let y as to be equal to 6, right, we can do something like this and do something like this. All right, and when we clear this and we try to run that again, we'll still get like the value 4, yeah, which is pretty cool. So that's basically how you use like named parameters. The next thing we're going to be looking at is statements and expressions. So function bodies are made up of a series of statements optionally ending in an expression. So far, the functions we've covered haven't included an ending expression, but you have seen an expression as part of a statement. So let's just keep all that. So it says statements are instructions that perform some actions and do not return a value, while expressions evaluate to a resultant value. Now let's look at some examples. So you can see this function here, which is basically created using like the let keyword, and we're assigning like a variable to it. So in this case, you call this like a statement. So this performs just the assigning action, right? It's not really like passing return a value. But for statements are like kind of like function definitions are also statements. The entire preceding example is statement itself. Statements do not return values, therefore you can't assign a let statement to another variable as the following code tries to do. So that's, if you try to run this, right, this is going to fail because you are basically trying to assign a statement to like this particular variable. So statements do not return a value, they just perform an action. All right, then looking into expressions. So expressions are stuff that return like a particular value, and in a function, right, if an expression is like the last, let's say the last line of code, like in that particular function logic, if you do not append like a semicolon at the end, the compiler knows to automatically return what's it called, that to automatically return that expression as the value of that expression, right, as the return value for that particular function, just like as we saw here. So everything we've been saying can be summarized under this, for example, is a statement, right? Because it does not evaluate to like a return value, so it's just assigning this to x, right? So but this in here is what we call an expression, because at the end it returns a value. So we could do something like we could see let z be equal to x minus y, right? Yeah, and basically return z. We could do something like this. So where this is z is equals to like the value we get and we return it, which is probably like a bit more clearer when reading the codes, right? But to make things a lot simpler, you could just simply do like what we did earlier, x minus y. So like I said, when this is like for example, as this is like the last line in like this function's logic, right? Once we do not append a semicolon, the compiler would know to like basically return this as the return value of this particular function. Okay, so now we have like a good understanding of the difference between functions and statements. Let's move on. So we already looked at return values. I think we were probably moving ahead of our probably moving faster than our shadow, right? So but I think that's as much as we need to cover under functions, right? So every other thing are just like simple examples we already looked at. So the goal of trying to achieve with this series, right, is to ensure that most videos are kept as short and as compact as possible. So we're going to be stopping here today, and we're going to be doing a continuation or a part two of the command programming concept. So we're going to be taking a look at comments and control flow, and here we're only able to like take the quiz as attached to like this particular sub chapter, so you can please attempt it and let me know if you were able to like pass all correctly down in the comments below. So we're going to be stopping here today. If you enjoyed the video, do me a favor, like subscribe to the channel, hit the notification bell, and of course share the video to as many persons as you know who are like interested in learning Cairo. Let's get more persons start built. And with that, we've come to the end of today's episode. See you in the next one. Bye.